First round 627 div 3f. This is a question on DP on trees. We'll be using uh, a technique called in-out DP to solve this problem. This is the problem statement. Uh, okay. Now the way we solve it is so let's consider an example first. This is the example given in the question. Sample example. Now we define Ndp to be the maximum count of white minus count of b possible in the subtree rooted at node. So what I mean by this statement is if our current node is 2, then Ndp of node would store the maximum count w minus count b possible in this subtree. Similarly, Ndp of 3 would store the maximum count w minus count b possible in this subtree. So this Ndp of 3 might include a path like this because this path lies entirely in the subtree rooted at 3. So this is a valid path in Ndp of 3. So okay, once we have got this cleared, now we have defined Ndp, now we define out dp, where out dp is the maximum count w minus count b possible outside the subtree rooted at node. So in this example, out dp of node would be all the maximum count w minus count b possible in this subtree. Okay, and similarly in count out dp of 3 would have been this, right? Okay, once we have cleared this, the two definitions, we'll see how these two are useful in solving the question. So the way we calculate Ndp of node for each node is a plain DFS where which looks like this. This is pseudocode. If color of the current node is white, then we'll store answer is basically dp of node in dp of node. We'll store in dp of node as 1 because the node itself is if we consider only the node in the subtree rooted at node, then the count w minus count b for a singleton tree would be 1. Similarly, if the color is 2, then the answer dp of node would be -1. Then we check that is it beneficial to increase the size of the subtree from 1 to uh, 1 to something else by including its children. The way we do this is check all the children, DFS in the children, and then we add the answer. We add to Ndp of node the value of Ndp of v if Ndp of v is greater than 0. So the logic for this is consider we have this is a white node, this is a black node, this is a black node, this is the black node, this is the black node. Now when we are here, we have Ndp of this node is equal to 1. We have initialized it. When we do Ndp of this, we'll store Ndp of this is -1. Similarly, Ndp of this is -1. Ndp of this is -1. Ndp of this is -1. Now, when we are having a look at the children of this particular node, we see that Ndp of this is -1, Ndp of this is -1. So there's no use in taking any of these two children because including this would only decrease the decrease the value that we are looking for, that is maximum of count w minus count b. So for maximum, whenever we see that a child has Ndp less than 0, that means that we don't have to include that child. So 0 is basically ignoring that child. Okay, so this is the explanation for Ndp. OutDP is a little more involved. So the way OutDP works is, first of all, we try to understand why we need OutDP. So the reason for that is consider 2. Now Ndp of 2 would have been 1 because this node would have been included in the subtree, in the optimum subtree. So in the optimal subtree, if only this node would have been considered, we would have reported answer as 1. But we can observe that if we take this subtree as the subtree containing the node 2, the value of count w minus count b for this particular subtree is 3 minus 1, that is 2. uh, 2 is greater than 1. So clearly we're missing something if we are only considering Ndp of node. So the way we handle this is when we use the values of out dp of node. So out dp of 2 is 2. That is the out dp of 2 would be the maximum count w minus count b possible in the whole of tree minus the minus the tree, the subtree rooted at 2. So yeah, so we calculate this via a DFS, uh, and we pass the uh, value of the out dp to the function. Okay, and now how do we, if we know the out val of a parent. So let's say this is uh, okay, let's say this is parent, and it's not a node. Let's say this is parent and this is child. Now the way we and we know the out value of parent from out dp pair is equal to out val. I mean, sorry, out val is equal to out dp pair. So the how do we calculate the out val for the child? Out val dash is what? Now the logic for this is out val dash can be written as out val. So let's say that for this parent, the out val was corresponding to a path something which was something like this. So out val for the child can be uh, can so out val for the child can be this path, that is the path from for the parent, optimum path for the parent, plus a node plus a edge inserted between the node and the parent, and rest of the thing is the same. So this can be one possibility. Another possibility can be that from the child we go to the parent, and then from the parent we go to a child of the parent which is not the child under consideration. So basically we need to include the contribution of the siblings of the child node also. So the way we do that is outval dash is outval, this is outval plus the contribution of siblings. So the outval is, we are already taking care, right? So every time we are saying that outval is the maximum of 0 comma whatever that is. So outval is always taken care of for the parent's outval is correct always. For the child, its outval can be would be the outval of parent plus the contribution of siblings. And the way we calculate the contribution of siblings is uh, we've already calculated the NDP of parent, right? So this is not node, this is parent, this is child. Okay, this is getting messy. Okay. NDP of parent minus maximum NDP of child comma 0. So the way this works is out DP contribution of sibling is this term, and the way we got it is NDP of parent stores all the information from this whole subtree, and Ndp of child stores the information for this subtree. So if we exclude this information from the whole subtree, we'll get only the siblings. So this is what we want: contribution of siblings. So yeah, this is the logic. Moving on to the code. Code is exactly what I just explained. We define an NDP. We define an NDP array, out DP array. Populate the NDP array via DFS in. Populate the out DP array via DFS out. Yeah, this is the code. Thank you.